Right, it's Mr. Bruner. Today I want to take a look at how to use Solidworks to do some simple linear static analysis. So what we're going to do is we're going to go into our Solidworks program, and I'm already going to use this default beam that I've created, and we're going to look at it in a couple of different ways. I created this very simply. I just made a sketch here on the side of the eye shape, and then I extruded it. If you take a look, we have about 6 inches wide and tall, only 1 inch on these, and it's 48 inches long. So in order to take this and actually produce the simulation, we're going to be taking a look at some of our tabs up here, or our ribbons, as you might also hear out in the world. And we're going to click on our simulation one. From here, we're going to go to our drop down and just click on a new study. If you're really kind of lost, you can always go to the simulation advisor and it'll walk you through all the steps, but I'm going to try to do that here too. Once this opens up, you'll notice that there's a very wide variety of different simulations that we're going to do. So we're going to take a look at some of these, but today just static. So we're going to go ahead and click that OK button. Now you'll notice that a whole bunch of new things pops up here, and we still have all of our tabs over here. Now the real simple thing to do is to start working your way down on here on the side. So the first thing that we're going to do is take a look at part 1. We're going to right click on it, and we have to apply a material. So SolidWorks gives you a whole slew of different materials. You're going to have to find out which one fits your purpose for your projects. But what we're going to do is we're just going to take a look at a simple aluminum alloy. I'm just going to do a very basic one. You can see that this has a lot of different information that you can take a look at depending on what you want to do, change, tables and curves, everything up here. What's also kind of nice is that if you find a material that has its yield strength, it'll actually show you whether or not it's going to fail or not. Then what we're going to do is apply. It doesn't actually close out of this, but we will close this window and we can see over here part 1, 1060 aluminum alloy has been applied to our material. We're good to go. So we're actually going to be able to skip the connections because we only have one part here, so we don't have to worry about how it's connecting with other parts of geometry. But now what we can do is we can tell the program where it's fixed. We're going to right click on this, and we can go to Fixed Geometry. Now you'll notice when I right click there's multiple different types of fixtures. We have those here as well, so whatever you pick you can always change it. Now we're going to do two different things, two different ways of fixing this. So the first way is we're going to make sure that we're in our faces and edge box here, and we're actually going to lock this down on this face here and the opposite face around the other way. So by just selecting the entire face, you'll see face 1 and 2 pop up, and you'll get how it's fixed in with all of these arrows. Once they're done, you can go ahead and hit the check box. The next thing that we're going to do is we're going to apply a load to this. So now that we've worked our way down, we can right click and we can say force. We get to specify how we are going to place the force on this. We're going to keep this one simple. So in our face region, face or edge region, we're going to click on just the top here. We're going to leave it as normal. We can select the specified direction if we want to change the angle. We're going to leave this as in the SI units, but we have the option of going English or metric, and I'm actually going to put 100 newtons of force. So once that's all set and done, we can go ahead and hit our checkbox, and now we have our fixtures and our force. You can see the arrows. Next we have to create a mesh. Right click, create mesh. Now this coarse to fine slider is all we really change here for very simple objects, and since this is so simple we can actually create a finer mesh and it won't impact the calculation time too much. If we have a complicated part, we want to go a little bit coarser so that it can go faster, but we're going to lose resolution on our actual simulation. There are also some more advanced features that I might get to later on, but now that we have this set, we can go ahead and click the mesh tool, and you can see it creates a mesh all over the entire thing. The final thing that we can do is we can run this study. So depending on how complicated, this could take a long time. It can also happen very, very quick. So I have run my study. You can see that it actually has this exaggerated deformation. So first thing that I'm going to do is I'm actually going to right click on the displacement, and I'm going to go ahead and click the show. Now the displacement gives me this nice gradient, and it shows me the spot that moves the most and the spot that moves the least. Now it's giving you this exaggerated kind of bend, and it's actually deforming this at a scale of 419,000 to 1. So this isn't going to move that much. You can see over here in our units is millimeters, and we actually have our scale 2.9 times 10 to the minus 4 millimeters of deformation through this whole entire thing. So we can change those, but it's not that big of a deal for what we're working with right now. So you can see the middle, which you would imagine moves the most. If we click on our stress, right click on show, it's going to give us the scale of the amount of force that each of the areas is seeing, essentially. Now this is where I was mentioning with the yield stress before. Right here at the bottom we have our yield stress of 2.7 times 10 to the 7th, and the maximum that our part is actually seeing is 3.19 times 10 to the 4th. So it lets us see whether or not our part's going to fail or not. And in this case it's not, because our units don't line up quite. But we can see that actually the most stress is coming in on this top edge right here. So by securing it like that, that's where all of our stress goes. Now, from here, we can continue to work on this model, or this might be enough. But I do want to show you how, depending on how you fix something, it can change the way that it actually interacts. So we can actually just come over here, right-click on our fixture, and we can edit the definition. I'm going to take these two faces and delete them. And instead of doing those faces, I'm actually going to click on the bottom edge here. Now everything else is already set up. I don't want to worry about changing anything. You can see we get a little exclamation point saying that these results are not set up for the current changes. So all I have to do is rerun this. And if you look at this number, you'll watch that the total stress that this sees now is significantly less. And that's because of the way that we have this fixtured. Now if we come and take a look at this head on though, you can also see that these tops are bending in. So that's why we're relieving some of the stress, and it's dispersed only on these bottom edges now. And again, if we show the displacement, you see that this gradient now extends all the way up into the top a little bit because it is free to move. So that's a really quick rundown of how to do some linear static analysis. There's a lot more that you can do with this depending on the complexity of your project, but this should get you started. As always, if you have any questions, comment, reach out to me. I hope this helped.